Okay, welcome back. This is factoring day 3. This looks different from the one I gave you, Mr. Hatcher. So you want to go to the website. I included the link to this page. The one I gave you is a little too easy. You can still do that one instead of doing this one, but you should get the same idea. Now notice on this equation, I have a mess on both sides of the equal sign. Well, one of the sides have to be cleaned up. So over here, I'm going to clean up all 3 of these terms. I need to get rid of all 3 of those terms. Alright, in order to do that, I'm going to add 7m. So I'm going to add 7m to the other side. Make sure you choose which one to add it to. Right? The 7m doesn't get added to 18. You want to combine like terms. So I'm going to add it to the 9m, or the negative 9m rather. I'm going to subtract 6, because I don't want it on this side. I'm going to subtract it from the negative 18. I want to subtract 3m squared. So I'm going to subtract from the 4m squared. And we're going to do that all at once. All that on the right goes away, it becomes 0. On the left, it's going to look like what we've been doing. It's going to be m squared minus 2m minus 24 equals 0. So now it becomes a regular factoring problem. So what are the factors of 24 that subtract to make 2? Well, 6 times 4 is 24. 6 minus 4 is 2. So we say m6 and m4. Now, which one gets positive, which one gets negative? That's the confusing part here, right? When it's a minus term, or back here, when your third term is a negative, they have to have different signs. That's how you end up subtracting, right? Because they have different signs. And you always want the bigger term, which in this case is 6, they have the same sign as the middle. So that's minus and that's plus. So let's double check what just happened. Okay, n times m gives me the m squared. That's why. Negative 6 times 4 gives me negative 24. That's why we chose those numbers. Okay, there are other choices, but negative 6 plus 4 also gives us negative 2. All right, that's why we chose these numbers, and that's why we chose those signs. Okay, now we set each factor equal to 0 and solve them separately. Okay, at this point you should be able to solve those linear equations pretty straightforward. Okay. I guess I'll keep working. Alright, number 2. Alright, so I still need to get rid of this 5n. But there is no n without an exponent on the left hand side, so I'm just going to kind of stick it in the middle here. And since there's nothing to add the 5n to, I'm just going to stick it in the middle. Now there is a reason why I stuck it in the middle. Alright, because we want the variables to go in this progression. You have n with a 2, n with nothing, and then no n at all. That's how we want to set up our polynomials to factor. If you don't set it up this way, they're not going to work out nicely, or it's going to be harder to see. So what are the factors of 6 that add to make 5? So that's going to be 3 and 2. Right, 3 times 2 is 6, 3 plus 2 is 5. And when you have plus plus, this is the easy one, because then everything's plus plus. And you can accidentally know, or accidentally get it right by doing plus plus. You probably don't know what that means, it's okay. So I get n equals negative 3, and n equals negative 2. There we go. Okay. Alright, let's do one more. How about number 3? Okay. So number 3, we still have this thing on the side, so we're going to get rid of that. And this time we actually have something to add it to. So we get n squared plus n equals 0. But this is not the normal factoring one. This is the one where you take out a common factor. So you take out n, and you get n plus 1, right? When you take an n out of n squared, it leaves an n. But what if there's nothing left when you take it out? Well, it's division. It's really n divided by n is 1. Okay, it's not subtraction, it's division. So we still have the n equals 0 and n plus 1 equals 0, which gives me n equals negative 1. Okay, I think that's enough. If you have more questions, you can always email me again. Okay, that is day 3. I will work on the quadratic formula ones at a later date. Should be enough for you to work on for now. Bye-bye.